Okay, so let's now start granting to our subblocks. Okay, so the first subblock, we are going to choose the largest one among the three requirements that we have for the subnet. So we're going to choose the first subblock. So we're going to start granting, continuously, such a way that we are not having gaps in between. The first subblock that we're going to take, the largest one will be 120, right? So now tell me how many bits you need for the host portion, the rightmost bits, so that you could cover up for 120 address, right? So the answer is you need 7 bits for the host portion. 128 addresses you can allot. So that's, since we are allotting in powers of 2, 7 bits goes for the host portion, which means 25 bits goes for your prefix part, correct? So already you have allotted this block, larger block 14.24.74.0/24. Now how many bits you need to borrow from the host portion so that you could grant it for your subnet 1, right? So you know that your subnet prefix is going to be 25 bits, which means you have to borrow 1 bit from the host portion. So the last byte goes for your host portion, right? So you're borrowing 1 bit from your host portion, right? So what does it mean when you're borrowing 1 bit from your host portion? Ideally the second level that comes, now it becomes a /25 block. So what will be the starting address of that sub block if I have a /25 as n sub 1, right? You have to set the first last 7 bits to all zeros, and for the first address, and set the last 7 bits to all ones for the second address. So what you will do is, say we have the last byte. I know that I have the right now to use, right, from all zeros, the last byte from all zeros to all ones. This many addresses I have, right? But what I'm now telling you to do is, you're going to borrow 1 bit from the host portion. So we are going to continuously do. So borrowed now, the first bit, you're setting it to 0. So you can't change this for the subblock 1. So this is borrowed now. These 7 bits you can play around, right? So setting all this to case here. So your first subblock n sub 1, right, will be /25, and the range of address will be 17.24.74.0/25. What will be the last address? This you can't change. This you all set to ones. You know that the 7 bits is all ones. It will be .127/25. So this is basically your subnet 1, right, where the subnet prefix is a /25, and you have used up from 0 to 127. Okay, that's for your subnet 1 here. So what will be the the prefix now? What will be the subnet mask for this particular subnet prefix? If you go on to, you need to have 25 ones followed by 0. So which will be what? 255.255.255. Right, 24 bits have gone. One more bit is there, which is 128 value, right? So that's the 27 ones. This is going to be your subnet prefix. So given any IP in that particular subnet, if you have the subnet prefix, you will be able to identify that this belongs to subnet 1. That's the beauty of your case here. Okay, so in the host portion, the first bit was 0 and it's been allotted for the subnet 1. Now let's go on till 127 is over. Okay, I have to now start allocating from 128 for my next requirement. Okay, so this is the moral here. So we've been looking at the subnet mask, right, and you understood that the first, for your subnet block 1, this is going to be the range of addresses that you have. Okay, for the second sub block, what is the requirement given to you? It's 60 block addresses that you need for your second address. So how many bits now is needed if you have to allot for 60 addresses for your host in your subnet 2, right? You need you have to allot 6 bits for the host portion. Now 6 bits is enough for the host portion, which means 2 power 6 will come to 64 bits. 64 address, I'm sorry, 64 address. So what does it mean? Right, you already know that 14.24.74, right, is fixed. Now the first byte 0 was used for first bit 0 was used for your subnet one. Uh, the last 6 bits now is going to be played around for subnet 2. But since 0 is already used, how many bits you need to now borrow from your host portion? You need to borrow 2 bits, right? Remaining 6 bits goes for your host. So when you're borrowing 2 bits, from the host portion, since 0 is already used, flip that leftmost bit, right, to 1, and then the next subsequent bit is going to be 0, because we are continuously allotting, right? First bit in the last byte was 0 for subnet 1. Now you need only 64 address for your subnet 2, so which means 6 bits alone is enough, right? The remaining 2 bits goes so that you could now go on to use it for your network subnet prefix. But you have to flip the higher order bit from 0 to 1, and the next bit you're setting it to 0 since it's continuously. So this is not changeable. This identifies your subnet 2. Okay. So having said that, if you set all the 6 bits or rightmost 6 bits to zeros, that will be the first address of your subnet 2. And if you set all that to ones, it will be your last address in the subnet 2. So can you tell me the range of address for your subnet 2, where you're trying to allot 64 addresses? What will be the subnet prefix for this particular case? Think of, right? So, how many? 6 bits have gone for this, right? 2 bits are borrowed. So it's going to be a /26 block now. Correct? What will be the first address of this particular block? 10 in the last byte is fixed. So it's going to be 14.24.74.128. Okay, will be the first address in that block. Till 127 it was already gone. So that's going to be the first address /26. The last address will be what? Set all the last 6 bits to ones. So it will be last 6 bits, if you set to ones, it will be 63 if I'm correct. Yes or no? Right? So all ones if you set the 6 bits, right? It will be 63 plus 128 if you go on. The last address will be 14.24.74.191/26. So if you look at here, we are having 64 address for the subnet 2, and your subnet prefix is /26. Okay, so the subnet mask for the second case will be 255.255.255. Now 2 bits you're borrowing from the host portion for identifying a subnet, which is basically 192. So any IP from belonging to this, right, if you go on to apply to the subnet mask, you will identify the first address of that particular second subnet. Okay, so this is the case 2. Now what is the third requirement now to allot to the least block? So that's going to be the last allocation that you're doing. 10 addresses needed. So if you need to allot 10 addresses, how many bits you need to allot for use it for allot for 10 addresses? You need you can't use 3 bits. It will only give you 8 addresses. So you have to use 4 bits for the host portion, right? So which means now 14.24.74, the last byte, if you look at, the first 4 bits is going for your subnet part, right? And the last 4 bits is only for your host part. So having known that in the last byte, the 0 identifies the subnet 1, the first bit 0 identifies the subnet 1, 10 identifies the subnet 2, right? Now for your subnet 3, you have to continuously keep doing on. So you have to now go on with flipping. So this is 1, the 0 now, the next higher order now flips to, so what's the next contiguous value? So 10 now becomes 11, right? It was initially 0, right? You flip that to 1, and this next order bit you set to 0. That's going to be subnet 2 for you. Now for subnet 3, from 2 it has to become 3, right? So this you flip the next order to 1. So this becomes contiguous. The remaining 3 to 4, since you're borrowing 4 bits, right? First 2 bits is 1, 1. The next 2 bit you set to 0, right? So this goes for your network prefix. Okay, so what does it mean now? The last 4 bits can be a combination of all zeros to all ones. So the first address of your subnet 3, right, will be what? Can you calculate and tell me what will be the subnet prefix for this? right? You now know that only 4 bits is needed for the host because 10 addresses only is needed, right? So 16 addresses you're granting, right? So 4 bits is only needed for the host, which means 28/28 is going to be your subnet prefix. What will be the first address? 14.24.74. Now this 4 bits now goes for your network prefix part, right? So if you go on to add the values of 128.64, it's 192. So till 191 we have already used for subnet 2, right? From 192 this is going to be /20. This is the first address of your third subnet. The last address, if you add up all the last 4 ones, right, rightmost 4 ones, it will be 15 plus 192 will be what? 207/20. This is the last address in your case. So if you have to represent this in subnet mask, it will be 255.255.255.4, right? So 28 bits of ones followed by 4 zeros, right? So all this, if you go on to put, it's going to be 128, 192, 224, right? And then 16. So it's going to be 240. So this is going to be a subnet prefix. So please be very careful when you're borrowing bits from the host portion. You have to be careful that you are contiguously allotting to the subblocks. So you are fixed in the first case, the first bit in the first byte as 0, right? That cannot be changed, and all that remaining you're using it, correct? Right, and the next case you're flipping the higher order bit to 1, and the next bit you are having 0. That identifies, this combination identifies in subnet 2. Then for your third subnet, you needed only 4 bits for the host, so you're borrowing 4 bits, along in the host portion to the network part, subnet part, and so you have to flip the next higher order to 1 1. So this becomes 1 1 0 0, right? And then you continuously do that. So till 207 you have used, but you know that you can use from 0 to 255, but you contiguously allotted till 207. You still have from 208 to 255 to be used. If there's a future requirement, you can use the leftover part. So that is the beauty of contiguous allocation, that you don't have gaps in between. You're contiguously allotting, but please be very careful when you're doing this subnetting. Okay, so I hope you're able to understand the case here. So we have allotted such a way that we took the largest requirement, 120. We gave 128 address, then 64 address. So the block is contiguously being done, but the subnet prefix, identified to that block tells you the size of that block, right? And you can go on to identify what is the first address in that every block by using the mask or the slash annotation. Okay, unused is still there. You future use, if you want to do that, you can still use that particular block, right? So that's the beauty of subnet allocation. Okay, I hope you got it. I want you guys to try out this again, the extension of this with another problem, right? Just try out. This is going to be a homework. 17.12.14.0. This is a block, one of the IP in that block given. You are given a /26 block, but the requirement now is right. You wanted to split this larger block, the /26 block, into 3 subnets, 3 offices. You want subblocks for 3 offices. One office needs 32 address, the other 2 office needs 16 address. So do the subnetting and tell me for each subblock what's the first address, last address, what's the subnet prefix, the subnet mask for that, and do your contiguous allocation following the rules of allocation, right? Contiguously allot and try out. I hope you will do that. And meanwhile, there's an interesting thing, right? So refer this subnetting example in the document, which whatever that I've explained you, I have documented this neatly, right? So you could apply this for your homework problem that I told you. And if you have any doubts, you could post it in the WhatsApp group. This is one thing. Alongside, it's a very interesting digital assignment. You don't need to submit it now, or but when you are practicing, right? You could play with these calculator. Week after CAT 2, you could submit this. So the subnet calculator is quite interesting. So go to this site. There are 2 ways, right? You can do subnetting. One is you're given a class A block, a class block, classful block, right? Whatever class block you're given and you want to subnet. That's called classful subnetting in classful addressing. The second thing is you have a classless block and then you're subnetting this. So whatever examples that we saw here was typically like, a kind of /24 was like a class C, right? So But the beauty is this, right? So you can do subnetting in classful block or classless block. So that's why there are two sites there. So I'll just show you that site. So this is subnet calculator. Okay, so here you can understand by just doing the calculations of how many hosts will be there in a particular subnet, right, and all the combinations. So in this is a classful subnet case where you're doing subnetting in a classful block. So say you're taking a class B block, you click on the B here, it will show you one of the address in the class B. You want to change and give, you can do that. But the point is this: by default, your mask will be 255 or 255 because 16 bits goes for your host portion. But now you wanted to split it up into, say, a class B block into 4 subnets. You are taking 2 more bits for your subnet, right? So, which means you can have maximum of 4 subnets. So what will be your mask bits now? Now it's not just 16 bits. You're bringing in a 3-level hierarchy. You're borrowing 2 more bits from the host portion. Your mask bits now will become /18, not /16 for your subnets, right? So in each subnet, you have 4 subnet. In each subnet, how many hosts you can have? 16,382. You know that every first address and the last address in every block you can't allot it. So you have to subtract that. That beautifully comes here, right? Having known the subnet mask, if you take the NOT of the mask, you get the wildcard mask, right? So the first address in that particular subnet, you get it. So what's the range of address that you have in this particular block, right? All that you could neatly, understand from this. So take a class, just play around with this calculator. Take a class C block. So 192.168. Now say I want to split up into 4 subblocks. So I borrow 2 bits from the whole subnet part. So I get 4 subnets, right? So now it's a /24 block. I have borrowed 2 more bits. 00 identify subnet 1, 01 identify subnet 2, 010 identify subnet 2, right? So your mask bits becomes 26, and effectively out of the 64 addresses that you have in every subblock, only 62 can be used, right? So that's the beauty. So what's the range of the address that could be supported? That's given here. First address you can't use, the last address .63 you can't use for the first subnet, right? So I hope you're able to follow this. So this is for playing with your subnet calculator for classful addressing block, classful block, either a class A block or a class B block or a class B. So just play around, give some IP that belongs to class C range, and then do subnetting, right? Play with different combinations and then do. So this is for classful. If you want to do CIDR, right, which means classless, block given to you, and you're doing subnetting for that. So enter the block that you wanted to play around, say 12.0.0.0, right? This block in which, say, 25 bits goes for your host portion, which means your network prefix, right? So with that, you could now tell that you have 7 bits for the host, right? And the number of subnets that you can do is you can use all the 7 bits, right? You can have maximum 128 subnets in that, right? So if you're just going on and trying to reduce the number of mask, right, then the number of subnets that you can do possibly goes on to increase. So this is something that you can understand from this. Say for example, okay, so if you're gone for 20 bits for your mask, right? The remaining 12 bits are there, so you could maximum have 4096 subnets, right? And you know that what will be the network mask if you have 20 bits on for your case there, right? So you will have your mask as 255.255.240.0, right? So this kind of playing with identifying how many max subnets you could play as basically have, right? You could try playing around with these combinations. So just play around with this. So I've given you a digital assignment based on understanding all these values, right? So given a classful block, right, you could take a class A block, depending on the number of subnets required, provide your understanding and inference on the subnet mask, subnet prefix length, the number of subnet bits that is taken, number of mask bits total, right, maximum subnets, hosts per subnet that you can have, right? So similarly for classless, given any IP address in a block, right, defined by the CIDR network mask, find out the number of maximum subnets that can be accommodated, maximum address that the block can support and all this, right? So this is something which you can play around along with your calculations that you do. I hope you're able to understand. So thank you.